Hi there, welcome to this lecture about the Mergesort algorithm. This algorithm is a sorting algorithm that, given an unsorted sequence, what we do is generate a new sequence with its values sorted from smaller to bigger. Like in this example, we have this unsorted sequence and we try to achieve a new sequence sorted from smaller to bigger. This algorithm follows a divide and conquer strategy in which the divide phase consists in splitting, as always, the problem in two subproblems. In this case, is creating two new subsequences with half the values on one and the other half on the other one. On the conquer phase, what we want to do is sort the sequence recursively until we apply to the case base, which would be having sequences of only one element, because these sequences would already be sorted. And finally, on the combine phase, what we do is merging the sequences to generate the final solution. So if we go back to the previous example, in this case we have 4 elements, so the first step would be splitting the sequences into two subsequences, 1, 2, 3, and 4. So that means that the first subsequence would have the first 4 numbers and the second subsequence the other 4 numbers. And we would go a new step. We split each subsequence into two new subsequences. That means 55, 22, 44, 66, 11, 33, 22, 66. This cannot be solved easily yet, so we go again. We split each subsequence in two and make new step. 55, 22, 44, 66, 11, 33, 22, 66. So now we have a sequence of a single element, which was our base case. These sequences are already sorted, so we can combine the solutions by merging its subsequences from 2 to 2. So in this case, we will merge these two subsequences, obtaining a new subsequence, 2255. These two, which are already in the correct order. Same here. Same here. And now, again. In this case, we combine each of them. The first and the first. Second and second. And the final step, which would be combining both of them. That will lead to the final solution. That's the first with the first. In this case, second with the second. 33, 44, and 66. So this will be the sorted sequence. Now we can see how to implement this in Python, and the easiest way would have using an auxiliary recursive function, so that we have our main function, which just uses the auxiliary function, selecting as the first position of the left the start of the list, and the right the end of the list. And what does it do, our function? As long as left is smaller than right, that means that we haven't go to the beginning of the list, to the middle, then we call recursively, splitting the problem in two. We compute the middle value of the list and make the recursive calls. And finally, for the combined part, would be invoking the merge algorithm. And the merge algorithm, what it does is to sort the two subsequences, storing it in the original vector. Now, regarding the computing cost, the divide and combine phases are the cheapest, have a constant cost, and as it's typical with the divide and conquer strategy, the conquer phase is the one with the bigger cost that is given from this equation. And if we apply the master's theorem, we would see that the cost of the Mergesort algorithm would be n log n. That's all for now. Thank you.